Cool. Let's get started. So overview for today. We're going to go over the answers to the written part for the midterm. Then we're going to go into a new concept with nested while loops. We've already talked a little bit about putting an if statement inside of a while loop. Now we'll put a while loop inside of a while loop, which can be a hard concept for students to get, but we'll try it out. We'll go through some different examples, and we'll continue with nested while loops on Friday. And then one part in the middle for the participation grade, because I need to get midterm grades in by beginning of next week. So let's start off with midterm answers. Let me grab people's signatures as well. Let's see. Cool. All right, so let's step through some of these answers. 125%. Okay. Most missed problem on the midterm. This first one. I think over 70% of students got this one wrong. How do we read the first part? X is less than 4. True or false? False. Or what is the second part?
Y is 6.
Y is 6. It's not, is it equal to 6? A lot of students thought false or false and put false for this one. The answer, mistake. Or I think one student put true, and I gave credit if he said true, because technically y equals 6 is always going to be true. And so this statement, technically, if you were to put in your code, would come out to true, and you would be confused, why is your else statement never running, right? Your if part would always run. So yeah, I think people know it. I think it's very easy for the human mind to do the one equal sign as two equal signs. All right, 6 greater than y minus x. True or false?
True.
True, because y minus x, 7 minus 4 is 3, and 6 is greater than 3. All right, z of 3 is equal to c.
It's false.
Okay, because we start counting at 0. So z of 0 is b, z of 1 is a, z of 2 is c, and z of 3 is k. So this one would be false. All right, this one trips some people up. We're taking the word back, and we're using this plus sign with the word pack. What happens if we use the plus sign on two strings? Yeah, it combines it. So in this case, we would get backpack, and that would be equal to true. All right, x is greater than or equal to 4. True or false? True. And then less than 6. Mistake. Why is it a mistake? Yeah. So the computer treats each of them as two separate sides, so you have to put the variable on both sides. And then y doesn't equal 7. True or false? False, because it does. Or x is less than or equal to 4. True. So we have a false or true. True. Any questions there? Yeah.
What was the first one mistake?
Y equals 6 is the assignment operator. And it needs to be two equal signs if we're checking equality. Yep. Okay. Debug my code. So 6 mistakes in the code. What's the first mistake people spot here? Line 1? Yep. What's wrong with line 1? Yep. IO stream instead of cout. Cool. Next mistake?
Line 4.
Line 4. What's wrong with line 4?
The main function is an int, not a double.
Yeah, so even though we're doing like double arithmetic inside, your main function, it's always going to be int main. And later we're going to talk about functions, and we'll explain why it's an int there. All right, next error. 5, what's wrong with that? Yeah, missing semicolon. So when we define variables, we need to put a semicolon. I still sometimes see in people's code they forget the semicolon when defining the variable. Okay, next line.
Line 6.
Okay, what's wrong with line 6?
The variable is being assigned in the wrong order.
Yeah, so the order is swapped, so it should be number is equal to 1.5. Cool. Next, sir. Okay, we'll go with line 7 first. What's wrong with line 7? Yeah, never defined variable square. So if we wanted to define it here, we could do double square is equal to number times number. Okay, and then I heard line 8. What's wrong with line 8?
Square isn't right now.
Yeah, so right now this would output whatever the number is, so it would print out 1.5 squared is square. Because we put square at the end here in quotes, it's treated as a literal as opposed to a variable. So remove the quotes around square to treat as variable. I think people did pretty well on this section overall. Any questions though? Everything makes sense? Okay. All right, while loop. Some misses here. So we want to print out all the multiples of 3 from 9 to 99. So first off, is this a counting or a validation problem? Counting, because we know exactly how many times this loop will run. We start at 9, we go up to 99. So 90 divided by 3, because we're going in increments of 3, this loop will run 30 times. So we know exactly when and where we want to start it. So where do we want to start this at?
9.
Yeah, the first thing, you'll notice we're C out the variable triple. And the first thing we want to print out is 9. So we want to start counting at 9, right? And then what goes in our while loop condition here?
Well, triple is less than 99.
Okay, so I saw this on people's code. What's going to happen when, so we print out 96, then we increase by 3 to 99.
So it's less than equal to.
Yeah, so we would check 99 is less than 99. That would be false, and we wouldn't print out 99. So in this case, we need it to be less than or equal to. Yep, does that make sense? Okay, and then what do we need to do at the end of the while loop to make sure we don't have an infinite loop here?
Triple equals to plus.
Yeah. So every time we want to increase it by 3, so the first time in the loop, triple will be equal to 9. Second time in the loop will be equal to 12, then 15, all the way up to 99. Any questions here? Okay. And then the final part, drawing the flowchart. So we're checking how many runs the Atlanta Braves and Boston Red Sox scored. Looks like Braves made the playoffs last night, so kind of timely. Okay, so what's the first thing we want to do in our flowchart?
Make a box.
Yeah, so make a box, get runs scored. Okay, and then what happens next? Yep, because we have an if statement. And what goes in our if statement? I guess it'll depend on our variables, but if we just had it like ATL runs is greater than Boston runs, we'll say. Okay, so in the true case and in the false case, let's start with the true case first. How can we get the difference in runs?
Atlanta runs minus Boston.
Yeah, so diff is equal to Atlanta runs minus Boston runs. And then note it's slightly different on this side. What would our diff be on this side?
Boston runs minus Atlanta.
Yeah. Boston runs minus Atlanta runs. If we did the same equation for both sides, then we would get a negative value if Atlanta was losing. If Atlanta had 2 and Boston had 5, and we did 2 minus 5, we would have negative 3, and that wouldn't make sense. So that's why we didn't calculate this before the if statement. We waited for the if statement to see which side was winning before we actually calculate this diff. Okay, and then what do we do after that?
We say they won by that many games.
Yep, Atlanta won by diff. And what do we do on the other side?
Boston won by that many games.
Yeah, I think maybe we were saying we'll just do it in terms of Atlanta, so we would just say like, yeah, Atlanta lost by a diff. Okay, and then both code paths come back together. and we just print out next game. I think people mostly got it. Flowcharts look good. The two big things that we docked points for were if you didn't add arrows, we took off half a point. And then if you didn't explain how we got the diff. Because I think in the practice exam I did say like I want to see like a box, or you could have combined it. Like you could set Atlanta won by Atlanta runs minus Boston runs, but we needed to see somewhere how to get that diff. Yeah, question.
So if you did that, but like there was some other way that you like missed points off of it.
Mhm.
What could-
Like I'll give back the exams so people can look over their exams and just make sure we graded everything properly. And if you have any questions on how something is graded or you think you should get points back, you can let me know. Yep.
So like, in an if statement, can you use the same variable to, like how you have difference for both? Can
Yeah.
you say if Atlanta runs are greater than Boston runs,
Mhm.
you do diff equals Atlanta minus Boston,
Mhm.
and then else diff equals Boston minus Atlanta.
Yep. Yep. And diff will just take one of those two values because we know only one of the code paths will be running.
So you don't need two separate variables for that?
Correct. Yeah. And if anything, it's kind of nice to just use one variable there. Yeah.
As long as the variables in scope.
Yes. So, which in our case it generally will be as long as you define it anywhere in the function. It'll be in scope here. Cool. All right. Any questions on the written part here? Okay. Coding part, I think people did pretty well. Common mistakes I saw. For this first one, the soccer example, what was a big one? Ask user how many ties, wins, losses they have. I think people did pretty well with this. Some people tried to add like while loops or if statements, and for this problem, it was kind of just a straight up arithmetic problem where we know it's always going to be the same code path. We always ask for the wins, we always ask for the ties, and we just multiply the ties by 3. We multiply the wins by 3 and we add the ties. So it's not like our code is branching and doing different things. It's just one code flow. The second one, bumper cars. Thought of this problem because I went to the county fair and saw the bumper cars like sign. This one, if, else for the 3 different cases. And then for the else case, you need to do some subtraction. So 42 minus whatever the user's height is would be the difference. And then for angel numbers, first off, angel numbers, is this a counting or a validation problem? Validation because we don't know how many times the user will put in like not a 1-digit number, right? To check whether it's 1 digit, I saw some people check like, is number equal to 1 or is it equal to 2 or is it equal to 3? What's an easier way you could do the check? Yeah, so essentially so there's 2 cases, right? If the user has entered something greater than 9 or they've entered something less than 1, we want to tell them to keep trying again. So either works. Technically, it's better code to do it with the greater than 9 or less than 1 as opposed to doing 9 different checks. Yep.
Can we see our coding problems on Edson from midterm or no?
They're hidden now. I've created like the makeup assignment that has the problems. But I kind of said what grade you got on each problem. And you can decide whether you want to redo one of the problems or not. But I can't release the midterm again because I need to save it for posterity. Yeah. All right. Any questions on the midterm? As a reminder, for the coding part, if you didn't get full points on one of the problems, you can go to the lessons page, do the midterm makeup by Friday night, and essentially, like, let's say you got a 7 out of 10 on bumper cars. You can redo the bumper cars problem, get back 1.5 points. Yep. Everyone good? Cool. And I'll pass back the midterms later in class, and you can look over how the grading went. All right. One thing I'll say for grading, as you all saw, the average for the midterm was pretty high, 88%. Hopefully you felt that it was fair. I kind of said if you've done all the homeworks and assignments on time, the midterm should play to those strengths. And I think people saw that. Like, that was kind of the biggest indicator. When I look at students who got less than an 80, a lot of it tended to be like not doing the assignments on time. That was the biggest correlation. So I'll encourage you to, if you've caught up, stay caught up, right? I don't assign that much homework in this class, but it can become overwhelming if you fall behind. So starting from today with the Wordle project and Lab 6, really make sure that you stay on top of assignments, and then you won't have to do a lot of work before the next exam. Yep. Sweet. Let's get into the material. Nested while loops. Okay. What are the two requirements for a while loop?
A condition.
Okay, what about the condition?
It's gotta be false.
Yep, it has to become false at some point, right? So it might be true initially, has to become false at some point. So usually involves using a variable. What's the second thing? Variable has to change in some way. So if it's a counting problem, we're generally increasing or decreasing the variable. If it's a validation problem, we're generally asking for new input from the user. While loop syntax, I think people understand the syntax pretty well. Big thing is just don't add any like else if or else or anything after this curly brace. The other thing is when you create the while loop, create your opening brace, create your closing brace, and press enter a couple times between it so that your code looks like this before you actually start typing, right? If you just start typing the code and then you forget to put your closing curly brace later, it becomes very hard to debug and figure out what the error is. Okay, so we're gonna get into nested while loops, and I wanna use as a motivating example, when you go to the gym. Generally when people go to the gym and they're doing exercises, they talk in terms of sets and reps. So if you're doing like the bench press, you might do 5 sets of 5 reps, which means like in a set, you'll do the bench press 5 times, you'll set it down, you'll rest, then you'll do your second set of 5 reps, then your third set of 5 reps. So you would do 25 bench presses total. I don't have that much space to do 25 lines of text here, so we're gonna do an example of 2 sets of 3 reps. And just in English, I wanna kind of go over the steps of what it would be like. So when you start a set, what's kind of the first thing that you do?
Start a set.
Yeah.
You gotta put what on first?
Yeah, so we'll say like get in position, right? Get in position to start set. So that would include like getting the weight on. If we're doing the bench press example, like getting under the bench, getting ready, right? So get in position to start set. Then we're starting the set. What's the thing we do next? Yeah, so we'll do our first bench press rep, maybe. So that would be like take off the weight, bring it down, push it up, right? So we've done 1, we're holding it above us. What's the second thing we do? Yeah, so second rep, and then what would be the next thing? Okay. And then we're just gonna do 2 sets of 3 reps. So we finished our 3rd rep. What do we do after that? Yeah, re-rack it, re-rack weight, and rest for a little bit, right? That's a weird word, re-rack. All right, cool. So that takes care of our first set. We rested a little bit, and then what do we do next? Yeah, exactly. So get in position to start second set. So we'll say get in position to get first set. Okay, and then what do we do after that? Yep. So we literally copy everything that we did in the first time, right? Yes, question.
So for the first one, I see how you purposely made sure you explained that was the first set for the first one and the second set.
Mhm.
Why don't you have to explain that that's the second set first rep for the bench press?
Yeah, so like why don't we say first set, first rep? We could. I guess mentally we kind of know when we're in our first set that each rep is part of that set.
Okay.
So I was just
thinking like coding wise, like when I
Yeah.
repeated exactly what I said for that, like would it affect it? Like,
So we could explicitly say it. We'll get into the example of coding this out, and we could include it. Yeah. Did you have a point you wanted to?
I wanted to say
Yeah.
that you would represent that just with indentation. Like the stuff that's beneath the first set would be indented.
Yeah. So technically, yeah. When we put it in code, it'll end up looking a little bit like this, so we know it matches. But we'll do the example. So, all right. First off, does everyone follow this example? Make sense? Okay. So now, if we were to put it into code, we generally know loops are going to be used because we're repeating certain lines. Like we know this whole first part is being repeated a second time. And if we were to do 5 reps or 5 sets, it would be repeated 5 times. So that's a good indication that we need to use some sort of loop. And then we'll notice even inside of one of these segments, this part repeats 3 times. So we know that's a good indication that that could also be represented by a loop. But let's break it down. So let's say we first just wanted to complete 2 sets. So I'll have you all in groups discuss 2 things to figure out here. First, so we just want to print out begin set 1, begin set 2. So what's the condition to make sure we go up to 2 times? And then what line should go at the end? I'll give groups about a minute to discuss. Well, we'll do the 3 reps part later. Right now, just focus on these 2 right now. Yes. Okay. Okay, let's bring it back. So, first part here. What condition are we trying to add to make sure we only do 2 sets? Yep, set is less than or equal to 2. And then what line goes at the end? Sweet. So first time, set is 1. 1 is less than or equal to 2. So what gets printed out here? Begin set 1. We'll learn the code for complete 3 reps, and then we'll say end set 1. Set will equal to 1 plus 1, which is 2. 2 is still less than or equal to 2. So we'll print out begin set 2, end set 2. Set becomes 3, and 3 is no longer less than or equal to 2. Everyone follow? Okay. So now, notice this complete 3 reps is inside the while loop, right? It's indented inside the while loop. So this next part of code, when we're doing the complete 3 reps, everything we write is going to be inside of this while loop. Okay? So let's figure out how to code this part, the complete 3 reps. So I have int rep is equal to 1 at the start. Again, in your groups, you can discuss what should go in the condition and then what should go at the end. Okay. Cool. I think I mostly heard it going around, but so what's the condition going to be? Yep. And then what goes at the end? Cool. So again, we just wanted to run 3 times. This is a counting problem, and we're just increasing by 1 each time. So the first time we'll print out complete rep 1, then complete rep 2, then complete rep 3, and we never print complete rep 4 because 4 is not less than or equal to 3. Everyone good with this part? Okay. So again, it's helpful to just kind of put the comment here of what you're doing inside of this while loop. And so now we know the actual code that goes here. So this is what it looks like for complete 2 sets. And then if we add in, the only thing we took our code from the previous slide and we added it in here. Does everyone follow that? Okay. So everything else is the same. The first time, set is equal to 1. 1 is less than or equal to 2. Let's actually put this in the code in the visualizer just to be super clear on what's happening. Okay. Okay, cool. So, okay, so we set equal to 1 to start. Is 1 less than or equal to 2?
Yeah.
True, so we start here. What's going to be printed here? Begin set 1, like that's printed to the console. Excuse me. Then we create this variable rep, and we set it equal to 1. So is 1 less than or equal to 3?
Yes.
Yep, so what gets printed here?
Complete rep 1.
Complete rep 1. Then rep increases to what value?
2.
Yep, which you'll notice here, rep got increased to 2. Still less than or equal to 3, so then we print complete rep. We could have, sorry, I forgot to put the end L. Let me just add it in. And we'll also put an end L here. Yeah, question.
So the only difference, so the difference between what you did on this one and everything else was you just put all the stuff that was in complete 2 sets and complete 3 sets. Only thing you did was add int rep equals 1. And that was right below the complete 3 reps.
Yes.
That's
Or so I mean, even in the code here, we for the complete 3 reps, we still had this int rep equals 1. So I literally just copied these lines and I pasted it instead of this comment complete 3 reps. I just copied and pasted that code here. Okay. Yeah. Yeah.
Does it matter where you initialize the rep variable?
So we could have done it at the start of our code too. We could have done int rep equals 1 at the start. The thing is, no matter what, we still need to reset it to 1 here. So let's see what would happen if we just deleted this line. So let's visualize this. Okay. So set is 1, rep is 1, 1 is less than or equal to 2. As you all said, we begin set 1. 1 is less than 3, less than or equal to 3, so we complete rep 1, complete rep 2, complete rep 3. What's going to happen here at line 12?
It's going to exit.
Yeah, so 4 is less than or equal to 3. So what line runs next?
Line 16.
16. So note that we don't exit both while loops. We just exit the inner one when the inner one is false. So we come to 16 and we'll print out what?
Set 1.
Yep. So begin set 1, complete 1, 2, 3, end set 1. And then we increase this to 2. All right, what happens here? Yep. And what happens at line 9? Yeah, so 2 is still less than or equal to 2. So we'll print out begin set 2. What's going to happen here?
It's false. Still false. Okay, so that's why.
Why is it false right now?
Because rep is still equal to 4.
Yeah, so we didn't reset it from the previous one. In our minds, when we're doing the bench press, we in our minds reset our count back to 1 when we start a new set. So we need to make sure our computer does the same thing. This is super critical. Like, people, especially when you're new to nested loops, a lot of people are going to make this mistake. So if you're paying attention to one slide in today's lecture, this is the slide. When rep is still 4, like what your code's going to do is it's just going to immediately come to the end and say end set 2, right? So if your inner loop runs the first time but doesn't run the second or third or fourth time, it's probably because you're not resetting the variable in the inner loop, right? So how can we fix this code to make sure that we print out the 3 reps for the second set? Yeah. It's like before we start the while loop, we just want to reset the variable to its initial value. Right? So you can define the variable, you can define all your variables at the top, but make sure you come back here and you reset in the inner loop back to 1. That way we can do 1 is less than or equal to 3, and we can run that inner loop again. Yeah? Does everyone follow this? Any questions here? Okay. So just to really hammer home the point. So we got the first set down. We know begin set 1, complete rep 1, complete rep 2, complete rep 3, end set 1. Now we come back to the top, begin set 2. Rep is 4 from the previous run, but we're going to reset it back to 1 because if you think about when you're doing the bench press, we're mentally resetting our reps every time we start a new set. So we want to do that in our code too. We set the rep back to 1, and so now we know rep is less than or equal to 3. So now we can enter the inner loop one more time, and we can print out complete rep 1, complete rep 2, complete rep 3, and set 2. Now set is equal to 3, So what happens at line 9? Yeah, so like set is 3, which is less than or equal to 2. It will skip everything inside this loop. So it will come all the way down to here, and our program will end. And our final output looks something like that, which pretty closely matches what we had put in our pseudocode. Any questions here? Yeah. I'll put up a screenshot of this one. Okay, I'll add it to the slides later. But essentially, I just took the code that we did from what we all did together. So I essentially took this and I just added some endels. Cool. Any questions there? One more thing I want to call out here. How many times did we have this like cout statement? So like this complete rep, it gets printed 6 times. But how many times did we actually write it in our code? We only wrote it once. But the code ran 6 times. Why did this line 14, why did line 14 run 6 times? Yeah, Charles.
Because it was dependent on the first condition of the while loop, and then also dependent on the while loop inside.
Yeah, so how many times does this while loop run? 2 times. How many times does line 13 while loop run? So it's essentially multiplying the 2 together, right? The inner loop is running 2 times 3 times to get 6 times total. Do people understand that? Follow that? Okay. So generally, if you want to know how many times like line 14 and 15 will run, it's how many times the outer loop runs times how many times the inner loop runs. Cool. Okay, so syntax looks exactly the same as a normal while loop, but now you'll notice the indentation becomes really important because we want to know what brace corresponds to which statement. So this curly brace is lined up with this while, so we know everything between these 2 braces is part of the outer loop, and code in there will run X amount of times. This curly brace, you follow it up, it goes to this while, so we know the code between these 2 braces are going to run X times Y times if the inner loop were to run Y times. Right? So in the 2 by 3 example, we knew the outer loop X was equal to 2, inner loop Y was equal to 3, so it ran 6 times. If we were doing the 5 by 5 example, the outer loop would run 5 times, the inner loop would run 5 times for each of those, so you would have 5 times 5 is 25. Yep. Any questions there? Cool. Okay. So at the beginning of the semester, I said this was going to be the breakdown for grading. So exams are 40%. So the way I see it, every student should be able to get at least a B in this class. Because if you do the projects, you do the homeworks, and you participate, that's already 60%. So even if you got a 50% on every exam, you would still end up with an 80 in the class, right? So I really want to emphasize that as long as you do, and also if you do these other 3 things, you're going to get over a 50 on the exams. Like people saw that in this past midterm. So realistically, like every student who does these 3 categories should, I think, be aiming for at least a 90% in the class, right? Because you just have to get a 75 on the exams if you do these other 3 things. If you did do well on the exam, don't take that as a reason to coast, because if you stop doing these other stuff, you're still this is only worth 40%, right? The exam. So if you did well on the exam, keep doing what you've been doing, keep doing the homeworks, labs, participate, right? For the participation, I said it'll be based on what you all think you're doing in this class. It's like participation and effort. So if you have your laptops, you can open it now. Otherwise, you can answer these questions on paper and you can go back and fill it in later. But in the Lessons tab, Lab 6, let me make it unhidden. All right, we'll take 5 minutes to do this. Oh, shoot, did I? All right. It should hopefully be unhidden, so you should be able to see it now. Essentially, the 3 things that I want you to answer. So participation and effort, worth 10%. Right now, just be honest. Like, the midterm grade is just for you to check in. It doesn't get saved on your transcript or anything. So really the grade that will matter is at the end of the semester. But I at least want you to know where you're at right now in the class. So question 1 is just, how have you shown effort or participated so far? I gave some examples of things you could try to list, but you can also, if you think you participated in other ways or shown effort in other ways, you can put that down as well. And I noted, like, try to be specific and try to provide numbers where possible. So question 1 is just, how have you shown effort so far? Again, if you don't have your laptop, you can do it on paper right now and then type it up later. Second question is, what concrete actions are you going to take going forward? So if office hours have been helping you, like, note that you would still come to office hours. Joining homework sessions, like, what are you going to do to, like, continue to make progress in the class? And then the final part is, on a score of 0 to 10, what would you grade your effort and participation so far? And again, this is just a check-in, so I'll just use whatever score you give because the grade right now doesn't matter. But at end of semester, I'll actually, like, verify the scores that you put in to make sure that we have a fair value. Yep. So I'll give people like 5 minutes to work on that. Make sure you hit submit for each of the questions as well. Just giving it a few more minutes. So make sure you hit submit on all of them. Can you raise your hand if you didn't get the midterm back? I know I missed a couple. Isaiah and Mark, that's it. Okay. Cool. Okay, cool. We're gonna go over one more section and then we'll end class for today. Everyone good on the participation form? And submit on everything? Cool. Okay, so Wordle. So really quick on the grading part. Projects are 30% of the grade, which is almost as high as exams. So this Wordle project is super important. You need to finish the starter doc by today, book an appointment by Friday. So there will be appointments today, Thursday, and Friday to go over your starter doc with a Googler. It's worth 20 points out of the 100 for this project, and it's really just graded based on effort. So even if you don't have the answers to every section, at least just put down what you don't know, and you can ask the Googler in the session. But you'll get the 20 points if you book the appointment and you show up, and you'll get 0 points if you don't. Right? Is that like everyone gets that? Yeah? This should be one of the easier 20 points that you get. What was that? The appointments need to be booked for today, Thursday, or Friday. Yeah. Again, to book the appointment, in your EdSTEM, you can open up in Lessons, the Wordle project, starter doc, and at the very end of the starter doc, once you finish, there's this link. Once you finish the starter doc, book an appointment with a Googler. So you click on that. Any of these 5 booking appointment links. So find a time that works for you. You essentially just go into their calendar, book an appointment slot that works, right? So a lot of slots for today evening. If you've already finished it, I'd encourage you to take a Wednesday slot so that you leave some of the Thursday and Friday slots for your peers, right? You just come into here. It should fill in like your name, your email address, put in your email address, and then just do like Wordle starter doc check-in. Yep. Everyone clear on how to do that? Yeah, John, question.
So I clicked on the starter. What part takes you to this one?
At the very end of the starter doc, so in section 9, at the very end I said, once you finish the starter doc, please book an appointment with the Googler TA, and you can click on that link. Also, so the zeroed section says make a copy of the doc, so you just come to File, make a copy. You'll call it Wordle starter doc and your name. You don't have to memorize this, it's all in the doc. Make sure you share the doc with my email as well. I haven't gotten that many docs yet, and I think people have started. So, even if you haven't finished your doc, still share it with me now so that I can at least have access to it. Yep, everyone good on that? Okay, let's go over nested while loops in the context of Wordle. So in class on Friday, we played the game where the answer was scorn. So we know all the letters should be green if we get the word correct. It's yellow if we know like the letter C is in the final answer but in the wrong position. So here we guessed it in the 0th position, but it should have been in the 1st position. And then we're going to say a letter is red. I know the actual game does gray, but we'll say red. Red if the letter is not in the word. So the letter A doesn't show up in scorn, so we'd mark that as red. If we think about this problem, we can think about it in terms of loops. Because essentially for every letter, we're just trying to see whether it should be green, yellow, or red. And we're doing the exact same code for each of them, and we don't want to write the same code potentially 30 times. So the way we can simplify this is with nested loops. And there's 2 loops we need to consider. The first one is the outer loop that will get each guess. And then the second loop is to get each letter in the guess. So if we're to think about this in a grid, you can think about like this top left corner being like guess 1, letter 0. Guess 1, letter 1. So like the P is guess 1 letter 0, guess 1 letter 1, guess 1 letter 2, guess 1 letter 3, guess 1 letter 4. And then we repeat. Guess 2 letter 0, guess 2 letter 1, so on and so forth. So we kind of have a grid structure. How many columns are there? I guess how many letters in a guess? 5. And how many potential guesses could there be? 6. So how many letters might we have to check? 30. So this is where we're seeing the nested loop, right? The outer loop might run 6 times. The inner loop might run 5 times, or will always run 5 times. So 6 times 5. Whatever code we write in that inner loop could run 30 times. So the nested loops. Let's first just start with this first condition, and we'll do it as a class. So the outer loop, each time in the loop, we're going to ask the user for a 5-letter guess. And so let's first just start. Let's assume there will always be 6 guesses, and we're starting num guesses at 0. What's the condition we want to do here to make sure that we get 6 guesses? Yeah, so num guesses is less than 6, because the first time num guesses is 0, then 1, 2, 3, 4, 5. So yes, num guesses is less than 6. And then what do we want to do to num guesses on this line here? Yeah, so every time the user puts in a guess, we want to increase guesses by 1. Right? The one other thing I'll add to the condition here is we also want to make sure that guess doesn't equal the answer. Because as soon as the user guesses the answer, then we want to stop playing the game. Yep. Everyone good with this outer loop? Okay. The inner loop. So now we want to get every letter in the guess. So we start the index at 0. What condition can we put here to get the 5 letters? Index is less than 5 because index will start at 0. So 0, 1, 2, 3, 4 will give us 5 letters. And then what do we want to do to index at the end? Yeah, so each time we want to increase it by 1. So index is 0. We reset it to 0 every time it runs. Less than or equal to 4, or you could say less than 5. And we increase it by 1 each time. And then how can we get this letter? So we want to get every letter in the grid. What can we do here to get the letter?
Letter equals guess equals.
Yeah, so looking at the grid, we know like this guess is power. And if we wanted to get the letter P, we could do guess of 0 to get P. Then the next time, guess of 1 to get the O. Then guess of 2 to get the W. So you can look through the slides as well, but yes, letter is equal to guess of index. And then the final thing you would need to do is an if statement in here to say what color the letter should be. Yep. All right, so this, I would watch the video lecture for Friday because we go into a lot more detail for this. This was just like the very fast recap. But really make sure you get your starter docs in. And then lab 6 is going to be today at 5 p.m. Yep.